Hi guys, today we're taking a look at lesson 11, definition of congruence and some basic properties. We are on page 115 of the textbook. And your target outcome for today is to know the definition of congruence and related notation. You will be able to prove two figures are congruent. You will know that there will be a sequence of rigid notations that maps one figure onto the other. You will also know that the basic properties of congruence are similar to the properties for all three rigid motions: translation, rotations, and reflections. So looking at page 115, we are going to look at exercise 1. And on exercise 1, it says, describe the sequence of basic rigid motions that show S1 is congruent to S2. The first thing I want to point out to you, though, is the symbol congruent. And when we write congruent, it's an equal sign with this little wave that goes over the top. That's congruent. And congruent means that these are the exact same. So we are proving that S1 is the same thing as S2. Okay, that's what we're doing here. Notice this one says S1, the top one says S2, and this far one says S3. Okay, so we're only working on these two. So how can we, using our basic rigid motions, how can we show that they're identical? Well, what we can actually do is we can use what we know, and congruence means that we're going to be able to place the one shape on top of the other perfectly. It is actually called a sequence of basic rigid motions that maps one figure onto another. So in the past, we would say that congruent, like a congruent triangle, and we would say this triangle is congruent to this triangle, meaning they were the exact same, okay? Same size, same shape. Now we're saying that we can map one shape onto another shape. Well, what is the first thing that we could do? Well, we could either translate, we could rotate, or we could reflect. So what are you thinking? Is there more than one way that we could do this? Absolutely, there is. I myself would translate this point to this point. That would be my first thing. In order to translate, what do I need? Yeah, I need a vector. And of course, I would use a straight line. And I'm going to call this vector V. So first thing that I would want to do is I would want to translate S1 along vector V. So now my shape is slid up. Not sure if I can do this on this. I don't believe I can. I don't think I can move it. So now we're going to have it, and it's kind of up here looking kind of like that now. And so now what can I do? Sure, I can rotate it, right? Rotate D degrees. Which direction? I need it to go this way, which clockwise. So I'm going D degrees clockwise around point. We actually don't have a point, so let's go ahead and label it. At least I don't have a point. Let's call it point B. And we're going to go ahead and clockwise around point B. And then the final thing we're going to have to do, now we're kind of looking like this, kind of like that. And so I need to reflect S1 across the long side of the shape. And onto S2. And it would be there. And then we showed right now that we took this shape S1, translated it, rotated it, reflected it, and it landed exactly on S2, which means that they are congruent. Easy, right? I know you think that. All right, so let's go ahead and look at the next example. Turn the page. We are looking at example B, and B says now we need to show that S2 is congruent to S3. So this time we don't need that first S1 shape, so we're just going to look at S2 and S3. What could we do to map or show the congruence S2 to S3? Yes, hopefully you see again that we can take our point. Oh my goodness. I gotta draw that better on here.
Trying hard enough.
Okay, that's gonna work. We're gonna go ahead and work with that. So again, let's label our vector. Let's call this one V also. So we're going to translate along vector V. And then what are we going to do? So now we've got it. Our shape is approximately like this. What are we going to do with it? Good. We're going to rotate it. And which direction and how far? Yep, we can go clockwise. And we're going to go D degrees. Once we go D degrees, if we rotate it right there, what do you notice? Yeah, S2 is congruent to S3. So that one only took 2 of our rigid motions. All right, let's go ahead and let's take a look now at the next page. Okay, so as we take a look at letter C, we notice that now it's saying describe a sequence of basic rigid motions that gets S1, so here, over to S3. So we're kind of comparing all of these different shapes to each other, okay? So let's go ahead and look at our S1. And how can we get it to S3? Well, we're again going to have to translate. So let's go over and translate it. There's our vector, V. So we're going to translate along vector V. And then what are we going to do? Because now that we have it over here, it's similar to this. I'm just going to try to draw it. Oh, beautiful. Okay, so it's kind of like that. What can we do with it? Now, I know you're wanting to just say to flip it over. And flipping it over, reflecting it would be fine if we had a line of reflection. But let's say we don't know one right now. What could we do now? Sure. Let's go ahead and rotate this all the way around, okay, until it's touching right there on that side. So rotate. Which direction is that? Clockwise. Good. Clockwise. How many degrees? Good. D degrees. Okay. And now our shape is kind of looking like this. Ooh, that's a horrible one. Kind of like that. So what are we going to do with it? Well, we're going to reflect it across the long side. So we can reflect along, not along, across the long side of the shape. Awesome. Now, as we see this, okay, as we take a look at this, what do we notice? Okay, did we have to do all of this work, all of these things that we just looked at? Did we have to do all of these in order to show that all of those, that S1 was congruent to S3? No, we did not, right? Because we know that if we have any shape, and in this case we had an S1, if we had a shape, I'm going to draw our little triangle right here. If we had this shape, and when I slide it or translate it, what do we know about that shape? Yeah, the sides are preserved, the shape is preserved, the angles are preserved. We know that it didn't change just because we did some rigid motion to it. So if S1 was congruent to S2, and we know that S2 was congruent to S3, then we also know that these two outer ones must be congruent also. Okay? So we can tell that if two things are congruent and two other things are congruent, if they have one thing in common, then they're congruent to each other. Pretty easy, right? Okay, you can head back to the classroom.